Sir, we are starting in just 2 minutes.
Yeah, sure. Take your own time.
Live recording of this event is also sharing on YouTube stream also is there.
Okay, great.
Okay.
Thank you.
Okay.
Yeah. Now it's 5 minutes.
Okay,
over,
sir.
right?
Yes, sir. We just
How
start
long
our
will
session.
wait?
Okay, sir.
Sure,
Thank you,
it's
sir.
left to you. I'm okay. For me, I'm sitting in my office.
Yeah. Yes, sir. Thank you, sir, for such a wonderful session. Or for a short duration of time, you have acknowledged us for providing us such a wonderful session. गुड इवनिंग टू ऑल. अंधकार से प्रकाश में लाने वाले, शून्य से अनंत तक पहुंचाने वाले सभी शिक्षकों, गुरुजनों को मेरा नमन. We are having an interactive session on the topic challenges and opportunity in geotechnical engineering. We have having a good excellent speaker for this topic is that GL Shiv Kumar Babuji. GL Shiv Kumar Babu sir completed PhD in 1991 from IISc Bangalore, India, after master degree in Soil Mechanics Foundation Engineering in 1987 from Anna University, Madras, and BTech in 1983 from Sir Venkatesh University, Tirupati. He worked as a Humboldt Fellow in Germany during June 1999 to July 2000 as a visiting scholar. Purdue University, Lafayette, USA during 95-96. He served as a president of Indian Geotechnical Society during 2017-20 and is the presently chairman of International Technical Committee on Forensic Geotechnical Engineering of International Society for Soil Mechanics and Geotechnical Engineering. He is fellow of ASC and also served as a governor ASC Region 10 during 2014 to 2020. It is a prestigious to welcome our excellent speaker. He guided 23, 18 PhD and 5 MS research degree and guiding 8 students for PhD. He wrote a book on soil reinforcement and geosynthetic, edited 8 books and proceeding and has a several publication, international national journal, about 180 in numbers, such a huge number, international and national conferences, more than 200, total over 400 in last 30 years. He received several awards such as John Booker Award for IAC MAG, Humboldt Fellowship from Germany, DST, Boykost Fellowship, and a few awards for the best research paper for Indian Geotechnical Society and American Society of Civil Engineering. Sir, we all warmly welcomes you at this platform. Kindly deliver your excellent session with us.
Thank you very much, Dr. Tiwari, and it's a pleasure to see that a lot of youngsters are interested. I would like to share my presentation. Is it possible? Okay, can I do that?
Yes, sir.
I can share, yeah. Share. Okay, is it visible now?
Yes, sir. It is visible.
Okay, I hope it's visible. Yeah,
Yes,
okay. First of all, I would like to thank the Indore chapter of the IGS, particularly the student chapters, for giving me an opportunity here. I'm very delighted that I'm speaking to you, and I came to Indore a couple of times, and Indore is always a great place. It's a cleanest city in India, and I'm not able to visit. I hope I will visit soon. With this, I would like to talk about the challenges and opportunities in geotechnical engineering. We all know, I think you started studying in geotechnical engineering that in all the civil engineering works, we start with soil mechanics or foundation engineering. Like we know about geotechnical engineering that we want to design proper foundations for buildings. That's a simple way that we should look at it. Normally, when people say that, what do you do? If I say I'm a foundation engineer, oh, you design a shallow foundation, they also don't know, many of them. But I want to tell you what are the things that we can do as a geotechnical engineer here. See, we normally talk about two subjects like, because this is also, by Prof Carl Terzaghi, who's actually a mechanical engineer. He wanted to, understand how to design foundations on soils. So he wanted to understand what is soil mechanics. So he coined this particular term called soil mechanics, and he developed so many concepts you will be knowing, right from classification of soils to the engineering property evaluation of soils and all of that. So here in the soil mechanics, we try to measure soil properties. Earlier, it was not known before his entry. Then we call geotechnical as a subject which deals with engineering. Like, you want to design a foundation, we call it as a geotechnical engineering subject. So it may even be an underground water issues. There are so many challenges. So in geotechnical engineering, we observe them, their performance of the buildings and the structures, all of that. And what we do in a typical geotechnical project is that most of the time we just take some soil for testing, which you must be knowing. Then you must have known about soil properties. Then you go to a design office, you get a design parameters, then design the foundations. See, you think of it's not a simple foundations. There could be dams, there could be big power projects, there could be landfills. There are so many projects that I will discuss with you that the its construction is taken up. But what is missing? I just want to tell you what is these challenges I am talking about. The thing is, we think that we know about foundations of all type of structures. Whether can I go for a shallow foundation or a deep foundation, or people think that they know, but then their practice is not much. In fact, if I go to a site, I can say that the foundation design is not correct because they would have. It may not be required, and it may even be shallow foundation may be sufficient. But then, because then assessment of the soil properties was not correct, so they must have done deep foundations. Something like that one can always comment. So the practice is not great. Transportation infrastructure, like if you look at it, of course, the people have proved that they can do very good foundation construction and all that things, particularly in even in underwater construction. There are a lot of things that we have developed. But when it comes to transportation infrastructure like roads, airfields, okay, you can see that we do payment design using geotechnical engineering principles, railroads, pipelines, rivers and canal networks, and ports and harbors, tunnels and subways. So a lot of transportation infrastructure is there here. And but then the practice is not good. My own assessment over a period of 30 years has been that the knowledge of geotechnical engineering would have helped them significantly in producing cost-effective designs, in producing more sustainable designs. I will tell you about that. What is that sustainable design? Okay. So a lot of things are possible, but so this is what I want to say. These are all one can do something normally, routinely, and but then how nicely you can do it in a way that it is cost effective, it's sustainable, is what we are going to see. Uh, Other important thing is that instrumentation and there are a lot of investigations, and nowadays it's not properly done. Investigation for big projects is also not carefully done, but there is a lot of scope for geotechnical engineering here in using advanced methods, because you should know that particularly the with non-destructive testing methods and other ground truthing methods, like one can scan the whole surfaces up to 30, 40 meters, and optimize the foundation design. And the instrumentation is very important because, say, when you construct large structures, I can tell you about what is the geotechnical structure. Say, for example, a big dam, or even a small dam, or a small tank bund, or even a landfill. So we need to understand the response of these geotechnical structures with the time, because with the time there is a possibility that because in geotechnical engineering you have a lot of particles, soil particles. There could be movements, displacements, and settlements, and all of that can lead to ultimate failures. And of course, earthquake geotechnical engineering is another area. So instrumentation is one way. Like why I'm mentioning is that the say, for example, if you construct a geogrid reinforced payment, and we don't do much in India, but if you're able to monitor its performance properly, come up with proper guidelines to payments, and then you can give it to IRC, Indian Roads Congress, and that will tell you that the payments are cost effective, not only cost effective, they're also sustainable. So that's one thing. And conditional assessment of geotechnical structures, like say, for example, the just mentioned about dams, but it can even be for even excavations. If there is a multi-story building and you want to construct excavations, people put a lot of the instrumentation for the excavations. And the conditional assessment is something, as I just mentioned, that with the time, many of these behavior of these materials, because of the soil is being porous, it is tricky. So conditional assessment of these materials are important, and they're also helpful for us to come up with geotechnical safety guidelines. Like I want to tell you that, like if you go to Hong Kong, since it's all Hong Kong has a lot of hills and soil, or the land mass is quite small. they have called Geotechnical Control Office. It's very interesting. But why don't you have such offices in hilly terrains in India? Like say for example, the Darjeeling or something, because you have a lot of landslides, right? So a lot of even in Delhi, there is a lot of soil contamination. So you can think of geotechnical safety guidelines. Like say for example, you think of Simla city, which is sinking. You always see a lot of collapses happening, landslides, subsidences, and all of that. So one should have in each place what is say for example Indore city itself. Somebody should be able to characterize the whole ground and tell that. This is the type of soil available, and there should be a single agency for everything. There should not be any fresh investigation. Mapping can be done, and maybe that could be in the under the guidance of the the Indian Geotechnical Society chapter of Indore and Indore chapter, and they can look at establishing some guidelines for most of the geotechnical works in the chapter region. Waste disposal and waste containment systems like landfills and with liners, covers, and all that. I'm not sure if they have an indoor the landfill, but I'm sure I know that their waste collection systems are fantastic. And I'm not sure if you have any legacy dump site, but most of the cities in India have legacy dump sites. Like, say, for example, if you go to Delhi, you talk about the Gazipur landfill, Bangalore. There are some 7, 8 dump sites. Go to Calcutta, Mumbai. They're all historically now they're becoming famous. Like or infamous, whatever you could call. And site remediation and environmental enhancement. This is a very, very important subject. Again, it's a geotechnical engineering because when there is a site and contaminated, you have to do remediation. In fact, the government of India is struggling. They have the Minister of Environment and Climate Change. They have investigations that are conducted in the country. Like if you go to that homepage and tell that what are the contaminated sites, it says there are some 400, 500 contaminated sites in the India, but I can say that it could be 10 times or 100 times more than that because every petrol bunk station is a contaminated site. To give us a simple example, a lot of contamination, and of course you have to measure the contamination levels, and if things are very bad, only it can go for remediation. We also know about earthquakes, landslides, expansive soils, floods, and the relation, this erosion problems and all. And people have been talking about the sustainability, okay, sustainability and all of that. So sustainability is another thing that I'll just mention. Resource recover and energy. So in fact, reuse of waste products. Say if there is a waste product that is in a powdered form or a particle form, if you want to understand the behavior, it's only the geotechnical engineering principle that help you. Like you will find out there is a fly ash material, and you have to find out fly ash. We know that it's waste material, but if we ask a mechanical engineer, he will not tell you how to treat a fly ash. Whereas you come to a civil engineer or a geotechnical engineer, he will tell you what should be its optimum density and moisture content and all of that. And he finds a proper use. Say, for example, it can be in the form of roads, it can be in the form of dams and whatever, any structures. So even preservation and restoration of historic structures is another important thing. In India, we have a historical, a lot of legacy. For example, Indore itself is so wonderful place, and a lot of legacy that, but there have some structures where we can contribute from structural or geotechnical perspective. So there are a lot of topics in geotechnical engineering, like laboratory testing, field testing, modeling, numerical methods, because that is such a, though you study as a 2-part courses or 3-part courses or 3-semester courses, there are so many topics here. Like if there is a building that you construct, or if you want to model it, you do a physical modeling, or there is some numerical methods like a computer modeling, numerical methods, we do it. And there are different types of soils in the country. In India, it's so, say, for example, you have expansive soils, you have collapsible soils, you have unsaturated soils, you have desert soils. The soil behavior is complex because no two soils behave in the same way, unlike concrete and steel, which are manufactured materials. And stability of dikes, erosion. This is another big problem in India, that where we have a lot of rivers, um, floods, embankment, dams, transportation, geotechnical, earthquake engineering, underground construction, tunnels, mega cities. Like, you go to mega city, there is always some excavation going on. Metro cities, any metro, I think, if you look at it, the problem is that they have not understood the underground behavior properly. Like, how do you look at facilities? Even you must go to either Bangalore or Delhi or any other place. Everybody all the government agencies will be very busy digging, you know, and they don't know, there is no optimized way of digging. If somebody starts digging, somebody stops, and after that, somebody again starts. It is a pathetic thing, and they never came up with a proper understanding of the geotechnical nature and of soil profiles, and try to put the facilities in the geotechnical in a way that, say for example, you have what should be the different facilities. Say for example, you have a cables, you have sewer lines, you have water supply lines, you have tunnels, and why can't you do in a systematic way, so that okay, you want to do something again, you don't need to excavate completely, and for that again, because there is not much planning there in because again it's a geotechnical construction. Though for common man, they say that, okay, what is that, to remove soil you have to put it back, but it's so expensive. If you look at a lot of budget that is there in many of the cities, is only towards this even the road construction. So why should you do a road construction quite repeatedly? You can see now it's a February month. Now March, many people have to spend money. You will see a lot of work happening in this February work, because they somehow want to spend the money without proper analysis and understanding. I have seen in most of the cases. It's a typical scenario. We have the interactive design and soil structure interaction analysis, offshore geotechnics, ground improvement, reinforced soil structures, soft soils, deep foundations, land reclamation, general engineering, tailing, mine waste, system performance, risk, field monitoring, forensic analysis, machine learning applications, sustainability, energy geotechnics. Um, so many topics are there in geotechnical engineering, like geoeducation. Okay, even what I'm doing is a geoeducation for you, to tell that, to take care of the soil, Mother Earth. Geotechnical engineering needs to be learned. Soil is something that is actually it's a it's a very good natural gift for us. And how best to use it? How do you understand it? Like lot of things are there. So what I just want to say is that there are a lot of challenges, and but there's a lot of research also. Like you go to IIT Indore or IIT IISc Bangalore or IIT Madras or anything, you will have a lot of active work going on, but there are a lot of gaps in the country. And what is the way forward? Like, I just want to give you some examples and what is we are missing. I just want to discuss, but it is itself is a big topic. I'll just cover a few and then take some discussions. So, soil investigations and interpretation, geotechnical analysis, and performance monitoring. Just three important topics in any building design or any structural design. So, site investigations are the most important, but this Tajagi said, okay, soil is not a uniform material, it's by nature, product of the nature. So it is not, the properties are completely different when you, because where soil and steel and concrete are uniform. So you can say isotropic and homogeneous, but I cannot say the same thing with soil. The properties change from point to point. And it's very difficult to assess the complete range of properties below a building. So not only that, in the case of steel or concrete, there are maybe a few simple tests that we are they're sufficient. Of course, you can do a lot of details also, but here in geotechnical engineering, first thing is that you're going to scan the complete area. So for example, we call a geophysical investigation, where the mass is, it tells you that, like, similar to scanning, where use electrical resistivity, the spectral methods, seismic methods, and all of that, to identify which are the weaker areas, what is the layering and all of that. And then you do a geotechnical investigation, wherein you try to identify the number of boreholes based on the geophysical investigation, and maybe depending on the what is the significant zone. So, for example, if I have a building of certain height and or certain width B, then you say 2B will be the foundation depth that investigation depth that is required. So you should say, because 2B will be the significant zone that which the soil will be a little affected because of the loading. You at least try to investigate, say if it is 10 meters of a foot, then you should at least go for 15 meters, 10 to 15 or 20 meters, so that below the significant zone, there is no surprises here. So, for example, there is a weak soil there. So there is a possibility that the settlement will happen in the case in the footing. So then there are some other types of investigations called the forensic investigations, like failure investigations, like why failures are happening. Then the other type of investigation called contaminated land investigations, like it is completely different. Apart from geotechnical, you have to do like the type of gas, say for example, methane gas present in the site. Like I have seen this sort of situations, like somebody told me, sir, can you do the soil investigation here? Then I went to the site. It's all fully saturated. Water table is at the top, and there are bubbles coming from inside. Then I asked him, why is this bubble? Then they said, sir, there is a old dump here, and now we want to construct a building here. Then I came to know that that's a methane gas. And nobody knows how do you understand this methane gas, and how do you construct a building on a site where there is a lot of methane. It's very dangerous, number one. I have seen it in my own practice. So contaminated site investigations are much more complex. And as you go deeper, and work hard, and you have to make sure that there are no much contamination. I should say an example here, that if you go to San Francisco and US and many other places, they're all particularly we call it Silicon Valley, but it's actually a contaminated area, because they have a lot of electrical processes and electronics devices. So you have to treat all of these electronic products to get what you want. So soil was contaminated, but then they really did a lot of decontamination methods, and that's why even whatever you have, say Google Office and many of those areas are all contaminated maybe 40 years back. Now they're all, because engineers were very clear that we can't waste land, and so they decontaminated the whole thing, and it's very good. So this is a complex, not easy. Structural design could be quite easy. I mean, of course, it has its own complexities, but things are not as straightforward as we see in other areas. Then laboratory and field testing, it's very difficult to understand how many samples are required. How do you do a field sampling? There's a field behavior is complex. Type of soils, like as I just mentioned, type of tests, drained and undrained, static versus dynamic, and empirical methods to, they do dominate investigations, because in the quality of investigations is quite poor in the country. And because of that, the design parameters also could be very tricky. So that way it's an issue. Challenge is a challenge. And to obtain the design parameters, we should understand the soil behavior properly, because as Tadzagi said, he gave this effective stress. Effective stress is nothing but the total stress minus pore pressures. I used to tell that the pore pressure is like blood pressure. Okay, so if the pore pressure is less, or it's a drained or something, then things are okay. So that's called drained behavior. Undrained, like in earthquake conditions or certain rainfall, when they come, the undrained behavior happens when the rainfall intensity is more than the permeability, the ability of the permeability of the soil. So the permeability of the soil is much finer, so the water enters and there will be pore pressure because it can't be drained. So that leads to lesser strength, and it can lead to problems. Influence of stress history, like it depends on what type of soil, was it consolidated, not, and all. It is a mechanism of failure. Like people talk about slip surface, log spiral surface, wedge failure. That's important. Zone of failure, I just mentioned about 2B or 1B or 3B or something, because when a load is applied, below the load, there will be some zone. And if the zone is good only, your structure is all right. If the zone is not good, then the failure is imminent. So the other thing is the nature of loading, like, is it a traffic loading? Is it an earthquake loading? Is it a simple one building that is standing, like a static loading? They're all important. And the types of design. Look, say, as I said, the normal design is like sometimes we just follow some specifications, like that's what we do in building. You put some column, you put some beam, and people who may not have experience, but they just construct some buildings. But somebody more serious, there is a lot of money, he employs a structural engineer or a geotechnical, of course, a geotechnical engineer or whatever, structural engineer you can say. So he will do a proper design where the loads are known, resistances are known, so you calculate a factor of safety for that. That's one thing. The third type is what is called probabilistic design, because we say that the loads are variable, then resistances are variable. So we use what is called LRFD design, load resistance factor design, because we apply loads factors to loads and resistances, and that is one thing. Then we have another type called sustainability based design. Instead of the column that you have, instead of a pile foundation, why can you go for a stone column? So that is another type, which is because concrete is more carbon intensive, and why can't you go for a foundation that can reduce carbon emissions? So that is sustainability based design. Then we have another design called resilient design. See, the resilient designs are that even if something happens, the failures are minimum. The effects are minimum. Like, say, for example, there is an effect of corona, but the man is very, very strong and he's all right. Okay, there is somebody is affected, but he's able to recover very, very fast. So that's called resilience. So there are different types and analysis. Like, you can make simple hand calculations. You can make finite element analysis. There are so many things. Even the performance monitoring. Like, say, for example, you can do a simple eye inspection. You can do, monitoring by certain equipment, or even you can do sensors. There are so many opportunities here. And I'll talk about design. Designs is that normally we try to say that the here, we always want the capacity should be more than the demand. So that is what is called factor of safety. But people say, should it be just more? Is it 1.5 times,
Sir,
2
sorry to
times?
interrupt you. Slides
Yeah.
visible nahi hai. Sir, slides are not visible.
Now, which slide was visible so far? Yeah.
So
Please
only
interrupt
first
me.
slides.
Why you're silent now? Why you're? Is it slide visible? Let us.
Sir.
Now, which slide is visible?
Sir, challenges in geotechnical investigation.
Okay. Let me. Yeah, you should. Okay, I'll just stop sharing and then again do that. Okay.
Okay.
Because it is for you. Like, I'm not talking to myself.
Yes, sir.
Because otherwise I'm
Yes,
talking. Is it visible now? Is it visible?
Sir, slide is visible.
Huh?
Screen is visible.
Now, third slide. Is it visible? Slides are moving?
No, sir. Slides are not moving.
Slides are not moving? What should I do?
Sir, sir, now slides are moving.
Okay. Maybe see. Now you're able to see the slide?
Yes, sir. We are able to see
full screen mode. Full screen mode, I hope. Full screen mode or no?
No, sir.
No, sir.
Huh?
No, sir.
Is it in what mode it is?
It in PPT mode, sir.
Presentation mode, right?
Presentation mode. I'm seeing your screen with slide coming later on.
Now,
interactive design and silent.
Now you're able to see the screen. Site investigations and interpretation is the title of the slide.
No, sir.
Stop sharing. What should I do? Okay, I will stop sharing. Then again, Yeah, you have 100 people. How should this? And what should I do? Indore PowerPoint. Yeah. Are you able to see this? Because I just see you're so good. I don't want to. don't want to disappoint you. Is it okay? Are you seeing this? Hello, Tiwari ji.
Yes,
Yes,
sir, it is
sir.
visible.
Do you know that you are seeing the Tarzagi photo here?
Yes, sir.
Yes,
Called
sir.
the photo and then geotechnical investigations.
Now, challenges in
Yes,
geotechnical
sir. It
investigations.
is
You saw
clearly
this?
visible.
Okay, you're seeing this. Okay, then this one, design challenges.
Yes, sir.
This I just mentioned just now about the type of design challenges.
Yes, sir. It
Then
is visible.
basic design philosophy, you're able to see this.
Yes, sir.
Like we always say, yeah, okay, we have not
Yes, sir.
missed much.
Everything
So
is
I'm going to
fine, sir.
talk.
Thank you, sir.
Okay. So the one thing, no, I was talking about different types of design. See, normal practice is that we go by some specifications in actual construction, but then we don't really look into proper design. That is a problem in most of the places, but design needs to be understood properly. I can give you some examples. And we use always a capacity versus a demand concept in civil engineering, and factor of safety approach we use. So when it comes to shallow foundations and pile foundations, the factors of safety are being used. And for the retaining wall, like you said, sliding 1.5, overturning 2.5, bearing capacity 2.2 or something. Seepage problems, factor of safety is about 5 times. Slope stability 1.3. So we have a little random way of telling these things, which is sometimes, you go to different doctors, he will tell you different, somebody says different numbers. We will not accept it. But whereas in civil engineering, we seem to accept that. There is a solution for this that I'll say. Okay. And even the serviceability is arrived based on the performance, assessment, and experience. That is okay. But sometimes you will not know about certain things which we are not familiar. Say, for example, you have a high-speed rail. What is the serviceability requirement for high speed in India? We'll not know. So, see, why is it? Is that because we don't know about our soil conditions? It's not. That's the reason I want to tell you that the high-speed rail, they were not ready. They're not confident. They're going for concrete type of structures, and they're not confident with the geotechnical practice using RE walls for high-speed range. So unfortunately, a lot of work is done, but at the same time, the people are not very familiar. That is because the serviceability state is something that's very important. We don't want high-speed rail that will sink, right? We are already poor in railway. You have seen our own platforms and even the railway design. So, but then there is a lot of knowledge also at the same time. That's where then highways and landfills, you don't have a factor of safety approach in highways, like we just say CBR, but you ask him what is the factor of safety of your payment design. It's not easy. Landfills, we just say no, somebody suggested a clay liner, so I'm using that clay liner. Did you check if it is working? There is no system. So the issue is in why these problems are there is that we don't know how safe is safe. Like, how do you assess? See, why the civil engineering in the whole profession, our interest is to ascertain that the why the factor of safety approach is used is you want to make sure that if it is more factor of safety is more, the safety is more. But it's not necessarily true. So we'll try to understand what is the risk. See, risk is nothing but when it fails, there is a lot of risk. Either it can be in terms of say, for example, road failure. It can be a traffic congestion. It can be reconstruction costs. It can be anything, life costs, anything. So, it can be in terms of the finance, loss of revenue, so many things. Are you able to see this now? Variability. Hello.
Yes, sir.
Okay, so why this problem is that why do you see so many failures is that in compared to soil, compared to rock and rock, okay, the compared to concrete and steel, the way the coefficient of variation is low, 8 to 10%. If it is a concrete strength, or modulus or something, or steel, the coefficient of variation. What is coefficient of variation? a standard deviation by mean value. Okay, that is quite low. Maybe it's 10 to 15%. But in soils, it's much higher. It can be as high as 30%, 40%, 100%, permeability. So that's the reason why it becomes very difficult to say the factor of safety is 2 or 3. Is it okay? I'm just trying to say that the factor of safety approach is one, but there is other thing is to say how safe is safe. So that is what is called a probability-based design or reliability-based design. We say that the reliability of the structure is 95%. Or what is the probability that the traffic jam is going to happen here? You will say that the traffic jam probability is very, very low. So the reliability of the junction is 95%, which means that the 5% of the time only of the measurements. You can in fact take measurements. Like that's all possible, and it will tell you about some distribution. So why these things are happening in engineering practice, particularly civil engineering, is that a lot of materials are variable. So they're inherently variable, like sun doesn't get up at 6 o'clock every day. It's 6:37 in Indore. I think the classical place for, Ujjain and all great places for time observations, So you always have observations of time. They're all variable. Then the sampling, you always say in India that I take only one borehole, no geotechnical investigation. So number of boreholes are not sufficient. So you don't capture layering properly. So it is called statistical uncertainty. Numbers are different because you're not certain. Then we also use some model uncertainty, what is called, you try to understand that there is a theory for bearing capacity or pile foundation. We use some formula. And whether that formula is valid for that actual conditions, because it is somewhat different than what we use, we don't check it up. That is called model uncertainty. We have a lot of uncertainties, and soil is variable. And so that's what is called, not only that, they're also having some scales. Like I can give an example of a road of say 100 meters, the road stretch is very good. After next 100 meters, there will be a lot of variations, like a bumpy road. Why is that? Because below the soil of this thing will be a variable. Like it can be a bumpy ride in some place because then you take only a CBR. No, it doesn't tell you. You have to really find out the CBR and its variations and minimize the variations in somehow so that you don't have a bumpy ride. That is called variability. I just mentioned that we want the probability of failure of this system to be very, very low. And its safety of the factor of safety being 95% most of the time. Like why I'm telling is that the factor of safety being more than 1, 95% 95% of the times is better than the just telling factor of safety 3 or 2 or something. Because if I take some observations of 100 observations, if I get calculations to tell me that it's 95% of the times it's safe, it's okay with me, rather than single values, which is wrong. That's why reliability is the probability that the structure will perform its structure during its pre-treatment lifetime. That's other time is also important. You don't expect structures to long last. They may have a design life of 10 years, 20 years, 30 years. So that's the reason why you need to have a lot of performance monitoring, lot of evaluation regularly, because annual maintenance, actually money is available, but we don't maintain it. So what is important is that when government of India is spending a lot of money, we need to provide reliability based designs. So not just the factor of safety, because factor of safety is okay, but we wanted to see that the probability that the factor of safety is more than 95% is what I'm interested. So why this is required is that infrastructure facilities need better design procedures. There are a lot of natural causes that are leading to failure. There are a lot of poor maintenance, which are man-made causes. Then limited available sources. Like if you come to Bangalore or any other city, they keep on digging everywhere. And then the municipalities, maybe Indore may be good, but some of the municipalities, if you ask them some money, they said there is nothing, like that. So it's always a problem. And not only that, the risk perception is different for different people. Like, say, if you go to a policymaker, you say that this road is not good and why don't you repair? He says, no. I think you can still use this road for 3 more years. Whereas you want, as a good car user, you may have a good car. You don't want that bad road to be, damaging your car. So your risk perception is different from car owner to road owner. So this is a very interesting thing. So risk perception is different. One solution for this is that are you able to see the things, slides moving and all?
Yes,
Hello?
sir.
Okay. One solution is that, as I just mentioned, reliability-based guidelines, like the 95% let us do. Even if you look at IRC guidelines, they say 90% reliability, 95% reliability and all that. Even LRFD they're putting. So even American Code of, many codes are available, but it is not taught in civil engineering so much, but in spite of its importance, but in top schools, like very good institutes that teach this. That is called reliability-based design. In this, what it means is that for a normal performance of the structure, the probability of failure has to be 0.001, right? 0.1% or something. Okay, say 99% should be the reliable. See, like if I are 95%, like we use in characteristics of concrete, you take 20 samples and out of which 19 pass, you say the 95% is the characteristic strength, which means that in the reliability is 0.95. But you're not doing the same thing for the building or for any road. Like you may take what is the probability that the road is good, like say for example, but you may say for a concrete road you may take samples and all that, but for a bitumen you don't do that, right? Mixed proportion, 95% thing, you can all the samples pass. If they're there 95% all the samples pass, then you're sure that your road is good, and you go take a subgrade, same thing. So all of this they don't apply, they just mention that. I just want to quickly run through some examples, like if your role of soil structure interaction. So you construct a lot of structures, but soil, how does it help in optimizing the structural design is something that people should know, because it helps a lot. I will give say for example, this is an excavation in next to a building. People don't. So we know that if you have an excavation next to a building, maybe nowadays 2 basements, 3 basements, people are going ahead. But you should have a micropile, or you can have a different types of ground improvement techniques are there, which many people don't know. With the result that it may lead to collapses of constructions, and it should be done using numerical methods, because the conventional methods, what is taught in the class, they're good for concepts, but if you want to understand the actual thing in the field, you have to use what is called numerical methods, in which whatever you're doing in the field can be exactly simulated, and you will see the response. So for example, this I was doing for one 20-meter excavation building, and I was just looking at bending moments and shear forces as I excavate, what happens. So I was even calculating the factors of safety, and my interest was that at node stage of excavation, it should fail, right? So bending moments need to be calculated, shear forces need to be calculated, factors of safety up to complete depth of excavation should be calculated. This is what we do, and if you want to have, one can have measurements also, right? So I want to talk about now soil fluid interaction. In fact, see, the soil is related to so many things. It is interdisciplinary. Like if soil structure interaction, then soil fluid interaction. What is this? See, if you're looking at landslides, it is definitely that rain comes, but because of the interaction between the water and the soil, there'll be pore pressures and landslides and all of that, erosion problems. There's so many things. Like I can give an example here. I hope you're able to see the figure of landslides, right?
Yes, sir.
Yes.
Okay. So the landslides are quite common, but we are very happy that every year there is a problem. I know, but we don't have a solution. I just want to give an example that in Hong Kong they have a geotechnical control office. Okay, and they have been observing for the past maybe 1985 to now 2000, now 25 years old. The moment after the geotechnical control office is established, you will see that there is a lot of work being done by them. Like a PWD, they just go and check and take care of all of these constructions, measure their performance. It's a very fantastic thing. It's a very good model. So these sort of things we have seen, a lot of floods everywhere. in many parts of the country. So what the solution is that, see, as I said, you have to do risk mapping. Risk mapping. Say, for example, landslides in a particular district, or even a contamination in a particular district. Risk mapping has to be done. Risk mapping is nothing but the probability of failure. Like, because you don't want to take risk. If there is a contamination level in some place in Indore, what is the probability that that influences a particular person? In what way it helps? People can take statistics of health, like how many people are exposed to a particular odor. All that can be done, and then you can do a statistical analysis of the risk mapping, right? The other one that I want to talk about is what is called the subject called transportation geotechnics. Though we have Indian Roads Congress, I can say that they're quite proactive. But when it comes to soil, road structure, infrastructure may be great. But if they don't understand the geotechnical principles, you can have potholes, you can have distresses because of the imperfections that come from the ground. The other thing that I want to highlight would be the geo-environmental engineering. This is a common with environmental engineering. Like I want to say, like for structural engineering, hydraulic engineering, you must be seeing transportation engineering, then environmental engineering. Like the common subject from geotechnical and environmental is landfills. Like as I said again, our then there is a lot of contamination. There is a contamination remediation. This is an example of a dump site in Mumbai, in Delhi. How best it can be remediated and all that. Not much, it's in many cities in the country it is there. It's in Bangalore and one of the sites, Leachate. It's in so-called electronic city somewhere. Okay. Of course, we have also, geosynthetic materials, which I think some of you will be knowing. They're ideal materials in geotechnical engineering. You can use geotextiles, you can use geogrids, you can use geocells, you can use geomembranes for road applications, bearing capacity improvement, and many other applications. That itself is a big subject. I request your coordinator to organize some lectures and programs on this. And not only that, we have a lot of innovative approaches in engineering. Nowadays, young people, like they are interested in what computer science, why the prospects in civil engineering are not good. What is happening is that how these new techniques can be used in civil engineering. That's what is important. I should tell you that, say for example, data analysis, data analytics, machine learning. If you want to use, I want to tell you that there is maximum data in civil engineering. Only thing is that we don't collect and then we don't analyze, and we don't provide proper measures. Like I just told you about statistics. Statistics is nothing but machine learning, nothing else. If you go to any machine learning class or start this thing, they tell you about standard deviation, mean, then random fields and all of that. Some should have some basis on this. Then you can do a data analysis better. Okay, so one can do use good apps. So for example, how many potholes are there? If there's an app to report immediately to the government, of course, Indore is nice, but in other cities, a lot of things can be done with ML techniques. Then sustainability-based designs. I just mentioned about geosynthetics. If you use them, the sustainability, the concept is that we don't want to emit a lot of greenhouse gas emissions, because of which there will be a lot of temperature rise, and we want our children to be safe, because climate is changing, and we don't want to bring in a lot of climate changes, because if you use a lot of aggregate in construction and all of that, there will be not okay. So we have to do something, and that's what is called sustainability based designs. Climate resilient designs, climate responsive designs I just mentioned. So if you use geosynthetics or ground improvement techniques, they're nice. And use of sensors for evaluation of structure during performance or doing whatever, it gives you a lot of data for analysis, and it may be even useful for many things. So there are a lot of opportunities in geotechnical engineering. Are you able to see the slide, please?
Yes, sir.
Okay, so see, the thing is, people are not sure as a civil engineer what are opportunities. But I'm talking more, see, there are a lot of opportunities as a civil engineer. It's only that you have to explore. Like I will talk about only, what is happening is that even the governments also, they don't know that there is a subject like this, then they can have a person like this, that is the other problem. Like I just gave an example of Geotechnical Control Office in Hong Kong, because they thought that it is required and the benefits are very huge. Like, there is a specialty that is there, and in a place where there are a lot of landslides, definitely that's required. So I'll give an example in a city like soil investigation interpretation, evaluation of design parameters, role of in their role in design structures and influence on costs. This I want to tell you, like 3-4 years back, I was giving a lecture in some place in some small town like Indore only. Somebody who is a student chapter president, after his engineering, he started a soil investigation company. Okay, I was very happy to see that. And when I went to work, then they said, "Who is doing soil investigation?" Then somebody said, "No, no, this young man is doing the soil investigation." I was surprised, and I asked him. Then he said, "Sir, I really got inspired by your lecture, and then I started a company." Mind you, there is no other company, and they were always coming to some nearby city, major city. But this man picked up a lot of things, and he is doing his best. That's very interesting. I found. So if the ground is not good, ground engineering is another specialization. There are so many companies. So if you do an MTech in geotechnical engineering, it will give a scope for ground engineering. Then I just mentioned geosynthetics engineering. Oh, that's a great subject. There's so many companies, at least some 20, 30 companies in India who are using geosynthetics in different applications. Of course, the technology, the problem is they don't know fundamentals. Some of them, I've been saying. There's not much stress. If only good people like you who have enough background, if they join, that's great. Then understanding sustainability principles and developing sustainability-based designs. In fact, nowadays, big corporates are asking, how much is the greenhouse gas emission you reduced, and what is the sustainability of your design? People are asking. If somebody is innovative, they can do that. Then understanding climate effects and provide climate resilient designs is another important opportunity. Data analytics. There is, so much opportunities. Status and prospects. You're able to see this slide. Hello. Hello.
Yes, sir. It is visible, sir.
Okay. Yeah, status and prospects. See, geotechnical engineering plays a significant role, and the state government, central government organizations should recognize. It's like there is a patient, but the patient doesn't know to which doctor he has to go, and he goes to some other doctor, and the operation is bad. That is what is happening here, and there is a lot of scope for geotechnical engineering. And I should say that there are, even people can start their own initiatives. That's where, because you have to really, you should be the drivers in this mission. And what is that as an engineer you can do? As I said, geotechnical engineer as a foundation engineer you can do. See, I have seen a lot of bridge foundation. There will be a bridge designer, okay, but there is no foundation person who can help me. I mean, he will have more knowledge on foundations, but he can be a structural engineer. So that's a good combination rather than only knowing something. So you need to understand some parts of geotechnical and optimize the design. Say, for example, there is a foundation for a bridge, and if the bridge foundations are so important, and even the whole structural design is important. So you need to really work on that and come up with optimized foundation design. This highway infrastructure is too much, but then you have so many problems, so many things, and cost. You say 1 kilometer, they say 20 crores or 10 crores and all that. But if you look at some analysis and do a proper analysis, can we reduce it by say 10%? It makes a big difference. Dam engineers, in fact, most of the dams we have in India, they're all aging infrastructure. Like I can give an example. The other day, I was talking to some department. That department is in charge of dams in the whole some 4 districts, but none of them know about dams in the sense the analysis of dams, like geotechnical analysis. They know about water supply, they know about concrete dams, but they don't know about geotechnical. And they sent me photos. It is a complete failure. Then I was telling, how can you do that? Then they said, sir, they want to fill up all the cracks in the dam. It's a dam, but it is not like, you can't, if there is the bones break, we have to have proper sealant. It can't be, it needs an experience even in surgery, right? Unfortunately, our engineering with respect to dams needs a lot of work. Like, you'll see a lot of seepage, and I have seen many times, and a lot of deposition of silt at the bottom of the dams, which can be used, removed properly, and recycled and all that. Geoenvironmental engineer municipalities need to take the help of these geoenvironmental engineers, and they have all the positions. They have to create these positions to see that there is no problem with the money. It's just about willingness to create more positions and try to take advantage of those positions. Like, otherwise, how do you do that? Now, you say data analytics. He has to really look at, say in a district level, there is so much data available, but nobody uses the data. So you have an opportunity as a geotechnical engineer, geoenvironmental engineer, sustainability engineer, data analytics engineer. Many people, all the governments can employ and all of that. So what I just want to say is that as a student chapter group, we have to take initiatives and impress the people that, see, the geotechnology is not about a subject, it's about protecting nature, nothing else. People have evolved this subject because of the love for nature and trying to make cost-effective designs, sustainability-based designs, considering all of that, because after all, at the end of the day, we are all engineers and we'd like to do a good engineering. And so updating at the field is very, very important. Like, fortunately, you're trying to talk to students. What is taught in the classes is completely, you're only preparing for exams. Here in student chapters, you're preparing for lifetime. Is a lifetime opportunities here. And the life is a God's gift, and we have to really do very well, protect nature. And I always feel that better geotechnics provide better world, and because you're trying to address natural problems, nature will ultimately protect you. Thank you very much.
Thank you, sir. Sir, some questions are from audience also.
Yes, sir.
Are there?
I'm so happy. They're able to see the presentation. Hopefully, listen.
Yes, sir.
Okay, thank you. Yeah, I'll stop my presentation. Yes, tell me.
Yes, sir. Sir, it is a query from Karthik Cherry, Bomna.
Okay.
Sir,
Okay.
can we use any other country code and design if any data insufficient using our current codes?
It's a very good question, actually. So, see, it is required to use. In fact, see, if the codes are insufficient, definitely we should point out that it's insufficient and use a better code existing, or even you can develop a code and try to say, for example, IRC, IS code. You can do that. It's a very good thing, actually. Yeah, I must appreciate that person. Yeah. Any questions further on that? So this, whatever I was telling you, that the LRFD code, that low resistance factor design code and all, it can be developed for many buildings, for many structures, because it's like I can give an example here that structural design is all LRFD, okay, but geotechnical design is not LRFD. So hi Nitin, how are you? Okay.
Hello,
so,
sir. Good morning.
Yeah, nice.
Good
morning.
evening.
Good evening. So it's nice that you're here. So the without proper, there's a design inconsistency that we say that the structures are LRFD, but foundations are working stress method. So it is not okay. But okay, as long as the structure doesn't fail, is all right. But we have to really look at proper design procedures. Yeah. Next question.
Sir, one more question, sir, there. It is general engineers.
Please, any questions?
Yes, sir. Sir, why do civil engineers are paid less?
Oh, this is actually, if you look at the long term, this is not a bad thing. It is, the thing is, tough gets going when you're really tough, right? In the sense, salaries are okay, minimum, but as you go on, the salaries are better. Like I have seen the salaries are quite good as you with the 2 years of experience or 3 years. So you find it's difficult to get people there. Beginning, it is maybe problem. That too, unfortunately, that's also our own system that has been doing it. They should have a minimum way, like since you're accepting the 10,000s, they are ready giving it. But if there is a minimum thing, like you go to a government undertaking or something, they have a minimum salary of say 50,000 or something. We see that. So unfortunately, our see, for building construction also we employ masons who are not educated. I mean, they may be good in practice, but they're paid less. But you don't employ a sophisticated construction. There are a lot of differences that I think it's more to do with our own culture than anything else. Yeah, he's teaching better or construction site engineering job. It depends on your interest, actually. See, like, teaching is something good job, but construction, if people like construction, so people want to do something hands-on. Construction is always challenging and interesting. Definitely, you have if you have innovative ideas, I think definitely I prefer construction, design and construction. In fact, if you're in the construction long time, it's possible that you may stop somewhere. But if you have all combinations, and and then the civil engineering is actually a lot of knowledge is there, and you have to be continuously learning. Then you will find it exciting. Okay. Yeah. Any more questions? Can a private faculty become a proof checker? Why not? I mean, I think contacts. It all depends on contact, right? If you know the person agency who is interested in taking your service, why not? Sir, flyers. I couldn't understand this completely. And can somebody translate and let me know? I can answer.
Sir, I'll do it.
Yeah.
Hello. Yeah, I'll do it, sir. Sir, he's asking. Nowadays, the fly ash bricks are used in the in construction field,
Right.
and there are some radiations issues which he heard from somewhere. So he just want to confirm whether the fly ash used brick is suitable for the construction or not.
Oh, so there is no connection. See, this is where you should do research, right? See, we want, I want to tell you that the flash is not available for construction. If you're lucky, you're getting flash because it's so much used. It's in demand. Okay. Yeah. I'll tell you that particularly certain flashes which have some cementing agents, they're much more in demand. So the radiation, coming to this radiation, unless we measure, prove it, don't believe it. Say you go to that place where then you can be a good marketing man. Just disprove it and take all that flash and sell it and make it whatever you want. Yeah. Is Geotech branch available for pursuing? Oh, is MTech? You have Nitin here. I mean, I can't say anything more than that. You have a role model here. Okay. See, you can do MTech, PhD, whatever you want. See, one thing, it's not about even, you should be jacketed into some positions. It's like understanding the geotechnics role. Okay. You can be a very good teacher. You can be a very good researcher. You can be a very good engineer. All of that. And it is more about, applying all of these concepts and these years. I don't know. I have seen a lot of people, they work for teaching for some days, then they jump into consulting, they jump into, there are so many people are there because you have a life of 50, 30, 40 years after 20, after 25, right? So some people may try to stick on it's all, but all possibilities are provided. But the key is that you should have passion in geotechnical engineering, nothing like that. Okay. Yeah. Yeah. Can I say what is it? Directly? What is this? I couldn't understand.
Sir, Geotech branch available for pursuing MTech.
Yeah, it's available, right?
Yes, sir.
Everywhere. Yeah.
Good evening, sir.
Yeah.
Yes, sir. Myself, Shubham Dwivedi, sir, fourth year student in SGSITS Indore.
Thank you. Yeah. Tell me. Yeah. I came to
Yes, sir.
college.
Sir. Yes, sir. Sir, I had a query regarding scope and opportunity in future. But sir, you have covered it very excellently. And sir, I got my answer. So, sir, thank you very much.
Yeah. If you need anything, you can always call on my mobile. I'm free for students.
Yes, sir. Definitely.
Right. Yeah. Yeah, average is 70 or 80. It is necessary to study up to MTech or PhD or do a job. Okay. See, the thing is, you don't worry about this marks. Even after BTech, actually, I thought after BTech that's the end of my career. Then I then I realized that my boss was a stupid. Then I thought I can't work with a stupid boss, because he was only trying to copy some designs here and there. Then I somehow managed to come out and did my MTech. Then I thought I went for teaching, but no. Then I saw in my college also that there is a very good MTech people. They're better teachers than the PhDs. But PhDs were given more respect than I thought. Okay, let us do PhD and solve this problem. I did my PhD. I think it is just it is just a way that we look at. But one thing, because after some field experience and teaching and all that, then I realized that you should just be passionate about whatever you do, and life will take care. And it happened. So that way you don't need to worry too much about 70-80%. I have seen 90 top rankers also working in useless jobs. But whereas an average fellow with 60-70% doing extremely well in life and injured in a job. So we don't need to really worry about this, because it's more about passion, quality, integrity, honesty. There are a lot of qualities. Okay, they shape the life and the career, everything, not just these marks. Okay, marks are okay, they're qualifying, but no, not necessarily the other way. Yeah. Any more questions?
Sir, this is enough one.
Okay, is it enough? Yeah. So I'm okay. You can. Thank you.
थैंक यू सर। और कोई सर से कोई सवाल पूछना चाहते हैं? उन्नति, आप पूछना चाह रही हैं? आपने हैंड रेस किया है। आप में से कोई अपने सवाल पूछना चाहता है, सर से डायरेक्ट पूछ सकते हैं।
Yeah.
थैंक यू सर।
Thank you so much.
आईजीएस के मंच से मैं बिल्कुल धन्यवाद देना चाहूंगा।
Thank you.
सर ने बहुत शॉर्ट ड्यूरेशन पर हम लोगों को इतना अच्छा एक लेक्चर दिया सर। और रियली एक जियोटेक्निकल फील्ड में जितनी अपॉर्चुनिटीज मिल सकती हैं उसके बारे में एक्सप्लोरेशन और जितना एक्सपीरियंस की जरूरत होती है, तो बहुत जरूरत पड़ती है। थैंक यू सर। थैंक यू वेरी मच।
Thank you. Thank you. Bye. Thank you. Bye, Dr. Nitin. Bye. Thank you very much. Great. Bye.
Bye, sir.
Bye.
थैंक यू सर।